That was bad. It's all right though.
J-Bay.
So let's say that this is the sun. Let's say that this is the earth. Because the earth would look pretty much like this if you were in outer space.
But the sun would look humongous.
Right? Blue marble. So what it's saying is if we go from here to here, we have this imaginary line. And we go, so this takes a certain amount of time. Okay? Now let's say that we go over here. And then this right here takes the same amount of time as that guy. What we're saying is when those times are the same, the area that's enclosed, those areas are the same. Okay? So it's real easy to understand that in terms of a circle, right? But it works for any ellipse. So the amount of time it takes between 2 points, if you go anywhere on the path and travel for that same amount of time, it's going to sweep out the same amount of area. And this is actually a result of this. Anybody remember what that is? What is it, Kellen? Yes, no change in angular momentum or conservation of angular momentum. This is an angular momentum result. Okay? So that's the second law. So the first one, if you see some celestial body, it's going to orbit in some type of ellipse with one of the suns that it's orbiting at one of the focuses or foci. Focuses is not a word. The second law tells us equal areas and equal time. It's a result of angular momentum conservation. The third law that Kepler noticed was that the square of the orbital period, so t squared, and the distance that the planet is to the sun or the star, or the cube of that average distance, they're related to some constant value k. And that's not a spring constant, okay? I want you guys to think that this is suddenly a spring.
That's the greatest waste of time I've ever experienced in my life.
What happened?
They walked in, they were like, hey, you know you're taking 5 AP classes next year? And I was like, yeah. And they were like, okay.
Oh, it was that thing.
And you had to go immediately.
I had to go immediately.
They didn't do this for us last year.
Now that I went to the board, I'm just like, oh.
I'm sorry that the PowerPoint seems kind of dull.
It's pretty good. Not too bad.
No, I'm saying the light, isn't the light pretty bad?
Yeah. Vargas, when you
Started
need to change the bulb. It's been saying you need to change the bulb for the past whole year.
The bulb hasn't blown up yet.
Okay, but like if you're going to change the bulb,
Jesus. Is that helpful or no?
yeah. What did I miss that was
Alright, so Kepler noticed this pattern when he took the period squared and the average radius cubed and he divided them, he kept getting this constant k value. He did not know what that k value was, he just knew that he kept getting this value. Okay? That's why when you guys go off and do experiments, sometimes you just need to play with the numbers. Now when he's playing with the numbers, it's not like he had Excel or a TI Inspire or something. This is all hand calculations and putting them on a nice graph and then saying, oh look, that line's almost the same as this line. Alright, very linear. Anytime you guys plot random data and you get a straight line, something magical is happening. So pay attention to it. Sometimes you have to start doing crazy things, right? Like who would think like, oh yeah, just square the time and then square the average radius and I'm going to get some magic here. Alright, or cube the radius.
What's that?
This is the second law. Okay? So Kepler did his best. This is the value he got. We still give him credit for the 3 laws, but he wasn't able to figure out the k value. Who's being figured out the k value?
Newton.
Who? Mr. Newton, right? Guy does everything, I swear.
Well, how old is he this time? 22?
He's the same time period.
That was when he was like locked in
He
his
was like
bedroom, right?
from like 19 to like 24. He was doing work.
That was like
He was putting in work, and then like at the second half of his life, he was just like counting coins in the bank.
No, he spent a lot of his life trying to turn random elements into
He
gold.
was an alchemist.
But we don't really talk about that because it kind of like the guy's brilliant, but then he's over there trying to take random stuff and turn it into gold.
he was like he locked himself in his room for like 6 years. And that's where he did all this stuff.
All right. All right, so let's go ahead and talk about Mr. Newton.
So you know how the second law.
So this is quite some years later, right?
I should probably read this.
So it took some time, but Newton again figured it out. Just like he figured everything else out. Makes me wonder if he's like a time traveler, right? It's like some brilliant physicist in the future that goes back in time and then.
Like he would have figured out a lot more than.
But that creates a paradox there.
Yeah, it does. But it'd be great for a movie, right?
Yeah, it's already a concept. It's called the Flash.
Did you say Orange is the New Black?
He said the Flash.
Oh, the Flash. That's the what?
I feel like Vargas loves Orange is the New Black.
He likes cuties.
I feel like you love that show, Vargas.
No.
He says no then.
What TV do you watch, Vargas? Like, what shows do you watch?
Can't tell you.
NFL Sunday, but
Elmo. Teletubbies. My Little Pony.
That was a big show.
Alright, so we got to figure out what Isaac Newton figured out. Newton figured out that K value. So again, Newton came up with this. You guys should know that. And all of the orbits of the planets are ellipses. They're pretty much circular. So we can model them as a circular orbit. The only time that they're really elongated ellipses is if you have multiple bodies within the system that there's a stronger gravitational pull. But for the most part, they're going to be nice circles. Or if there's some weird asteroid that got in a really elongated ellipse. Okay? What's up, man?
some part like Mars, some other shit is really sample.
Does some part of Mars come into...
Some like moon size.
Well, the Mars moons, Deimos and something, they're not really spherical because they're basically asteroids that had a collision and then got trapped in it.
Earth, like when it almost first created, right?
My guess is everything was probably hitting everything when it was first created. Because it was just like a collection of matter that started to group up. Alright, so I think it's time to derive. Let's see. Yep, time to derive. Yeah. Alright, so we say that the force centripetal is equal to the force due to gravity.
Just what's your YouTube channel?
J/-edu.
J-Edu?
Yep. AP Physics C.
You know it's right because you'll see a ball head again talking.
Yeah.
So FC equals FG.
Wait, what are we deriving?
So FC, we're trying to put ourselves in Isaac Newton's place. Although we have a nice facility. He was in a cabin with a cat, trying to escape the place.
He locked himself in there.
But he did escape it.
So FC is mg squared over r. Don't remember that, you need to go back in.
MAC.
Yeah, Mexico City's my city, right? Most of us. FG.
Big G.
Big G.
M. F.
M little m.
R over R.
Over R squared.
Over R squared.
Over r squared.
All squared.
Play like that. Alright, so we notice that the little mass cancels out. So we have v squared over r gm over r squared. Let's move the r over here. So we have v squared equals gm over r. And we need the time in here. So v equals 2 pi r over t.
Oh, it's like a circle, right?
So we go in we walk around the circumference, and it takes a certain amount of time.
That's the period, right?
This is the period. So we have d squared. This is 4 pi squared r squared over t squared. Now we got to substitute.
Is r the radius?
R is the radius. So we have 4 pi squared r squared over t squared equals gm over r. And we want to isolate r cubed over t squared. So r cubed over t squared times 4 pi squared equals gm. We want to get this by itself, so we divide both sides by 4 pi squared. Yeah. And notice that this is the K value.
Is that really?
Yep.
Wait, so who came up with G? Who came up with
Newton.
I mean, count everything, man.
What did he come up with?
So when you guys go off to, you know, those big UCs and there's 800 people in the lecture hall, and they're like, who came up with this? And if you're in physics, just be like, Isaac Newton. Most of the time you're going to get it correct. And your colleagues will be in awe of you, like, man, this guy knows everything. Or this girl knows everything. Right? There may be that 10% that you like, they'll be like, no, it was Einstein, but at least you're close. Okay?
Or to Maxwell.
Oh yeah, or Maxwell. Yeah, Maxwell, Isaac Newton, Einstein. Those are your three guesses.
Maybe Bohr in quantum physics.
Or Schrodinger.
Or sorry.
Good, you guys are starting to accumulate those people.
Point, sorry, trying to get ahead of you with this.
So why is this K value a constant?
Because those are all numbers. Yeah.
Because these guys are all constants. And this guy is what?
Is the mass of the sun?
Is the sun, or the star that they're orbiting.
Also, technically,
So if they're all going around the same star, they're all going to have that same K value.
and what equation do we see this case?
This equation.
That's the third law.
So this is how we could figure out the period or the radius in which it's orbiting. So you guys have any questions on that?
Wait, leave this last bit.
So this is the actual, this is the K value, this is the actual equation, okay?
And so Newton said like it wasn't ellipses like from the top view, it was circles, and that's how he proved it.
I'm sorry?
So like,
No, he made the assumption that it was pretty much a circular orbit. So it's so close to being a circle that this works. All right, so this is the equation that we're going to box, okay?
yeah, so you're on the actually.
Nice box around it. This is Kepler's third with the help of Newton. Just realized my P looked like my E.
Kepler's third is the
Kepler's third with the help of Newton. With the assist, yeah. But we'll give it to him. He did most of the work anyways.
Kepler?
So like Newton was that inventor that like took everyone's idea but like made it better.
Newton has messed up.
Kind of.
Yeah, you can say the same with Einstein. Though. He took Newton's ideas and then just said, well, what if time was not relative? Or the same for everybody? It's like, ta-da!
Lo and behold, everything is right.
That'd be weird if we could perceive time differently. Like people age differently.
I mean, technically, depending on your circumstance, they do.
And if women
Now, if you,
besides, they
Are you saying
age.
maybe these power points?
No.
Yeah.
So why do you get too many slides on every power point?
Because I'm trying to get through.
So much learning all the
So
time.
depending on the units, you could actually put these units in such a manner that this becomes one. We're not going to do that, okay?
You don't have time for that?
So you can actually determine the mass of stars using this method.
Wait, it's speed of light. Or light years.
So if you know, hold on, let me fast forward. Geosynchronous orbit. You guys know what a geosynchronous orbit is?
No.
So geo, Earth, synchronous time. So we put a satellite in a geosync orbit so that, for example, most of your communication satellites are geosynced. Because you don't want to be on an AT&T satellite that's moving. Because you'd be in a phone call and all of a sudden it's over China and you lost connection. Okay? So they put it in such an orbit or such a location that it stays synced up with the spin. Yeah.
Are we gonna go over that?
We will. We're not running out of time.
That's crazy.
There's geosync orbit,
How many satellites are there?
heck of satellites. So much so that if you went out there, we have a ring of satellites in that geosync area.
Why do we have so many?
Because we like phones and TV and all that stuff, and to spy.
Imagine like
And
one
some of
day
them are just broken and old.
we can't.
So if you went out to this geosync distance, you would find that there's a whole bunch of space junk. Because that's what we do.
So like, how do we get rid of the space junk?
You have to go
You
make
give it
more.
a boost and kick it out of our orbit.
Well, what
Or you can give it
they
a
kick
tiny,
back?
or you could give it a tiny kick towards us, and then it'll fall and spiral in.
But if we kick it towards us, wouldn't shoot it like that?
Yeah, you would.
Unless you shoot. Oh, yeah, it doesn't matter how you do
Launch a nuke into space.
it. Launch a nuke into space?
Yes. Sounds pretty good, man. Sounds like a great plan.
Okay, so write this down for a geosync orbit, please. I do apologize for skipping a lot of slides, but we are running out of time, so I'm trying to give you guys the most important pieces. Sure.
It's next week when AP tests start.
So our next project is putting a satellite in the geosync orbit, right?
Well,
No, let's do it. Let's also launch it like in soccer.
Sorry?
Our next project is entering a satellite in the geosync orbit.
Yeah, that's gonna be your next slide.
They'll just fire it off with the soccer.
Yeah? Good time.
Mr. Vargas, what do you normally do with your classes after AP testing?
We keep learning stuff. Some of my colleagues will say that they've done their job and now it's time to party. But
Vargas, that is definitely what you said.
no, I'm trying to get you guys to learn stuff as much as possible.
You should teach us about E&M because I'm taking the physics subject test in June and it covers E&M.
Oh yeah, no, it covers some harmonic motion.
hey,
Fun stuff like bottle rockets
bottle rocket. I don't know what.
We'll see.
Jaden,
Geosync orbit.
Jaden, you're thinking AP, taking that subject test. Hey, Luis, you signed up for it yet? Subject test? Sign up, man. In South Admin.
Go to Admin South. They pay for everything. Admin South for
The
subject
physics.
tests. The physics and Math 2 subject test.
Just take the physics. Only take physics. Study for the math one. Yeah, if you want to. Hey, you better do it. There's a deadline.
The deadline's May something for the June test. It takes like 20 minutes. The signing up takes 20 minutes.
Well, if you've already signed up for SP4, it'll take less time.
That was good times.
Like June something. It's after AP testing.
I think maybe like 4
Like a
people
month
got that,
after.
right?
It's June 3rd, yeah.
June 3rd.
Alright, so I derived the geosync orbit equation for you guys.
Do you want us to do it too?
Just write down the thing and then you guys can, like, for homework or when you're on a date, you can just take out a napkin and derive it.
Hey, Alex, that sounds like you.
I've done that multiple times by this point, actually.
Let me see if I can put a white background on it, okay?
Oh, okay.
Thanks,
Okay, guys.
Just make the text white. Jesus,
You guys ready for that?
Because I'm reading back buttons.
All right.
How did you do that so far?
Probably just.
You click on the image and give it a background, huh?
My first job after college was fixing art. Yeah, and then gave me a bunch of art to the store and I had to make sure you were
How much time do you have?
Actually, I started off there. This is crazy. I quit. I was like, okay, I'll give you 50 cents. And I was like, this is still crazy. I was like, okay, $100.
Did you know in some colleges you can't? Well, this makes sense, but you can't take notes and sell them for commercial use, which makes sense now that I think of it. And Stone, did you know that Jews are the bane of humanity?
Of course they are.
Am I wrong though, really? Can you prove me wrong?
I can't if you prove it right. We all know the truth.
Hey, here's AP test score. Like, it tells you what score and like what credit you get.
Hey, Paula, won a Fresno Unified Scholarship! There you go. Good times.
Oh, no, that's technically.
Paula's going to Mars. Yeah, Biden is Fresno Unified School. Yeah, the whole mission. Potatoes and everything. Right here.
Did you like the part where
So one time, my friend was sister, got 70
I'll take that. Dude, I just gotta go. I gotta go.
Good job. I'll run back that information right now.
There you go. Did I get a scholarship? I did, but my counselor didn't write my letter of recommendation. So he was for youth. And then he's like, yeah, he's a good guy. Good time.
This Hendrix almost going to do the same thing for me for FCC.
Alright, geosync orbit. We talked about kinetic energies. Showed you guys this.
Lean back.
Total energy. So remember I told you guys about negative energy?
No.
No?
Yep,
Negative potential. So we're in a bound state until you get above the negative energy per free particle. Escape velocity. Talked about that. Alright, so this is the last slide. This is my top secret data for you guys. You gotta turn that off now.
Really?
Yeah.